Hi guys, today we're going to learn about one-to-one functions and inverses. So in this section, I will go over the relationship between a one-to-one function and inverses. I will determine if a function is a one-to-one and the properties of inverses. Finally, I will go over the steps in finding inverses. So let's go over one-to-one inverses. So we're going one-to-one functions and inverses. A one-to-one function is a function is one-to-one if no two ordered pairs in the function have the same second component and different first component. So what that basically means is you cannot have the function cannot have the same y values more than once. So that's pretty much what a one-to-one function is. Another method to determine if a function is a one-to-one function, and this is probably the most popular way, is the horizontal line test. So okay. So the horizontal line test a function. So a function is a one-to-one function if and only if each horizontal line intersects the graph of the function at one point, at most one point. So basically, if the horizontal line hits it more than once, then it's not a one-to-one function. Okay, so here's an example of what's not a one-to-one function. So let's say you have a parabola y equals x squared. If you put a line through it, a vertical horizontal line through it, notice it hits it once here and then another time here. So that's a total 2 times. So it's more than once, so no, it's not a function, not a one-to-one function. And as you can see over here, this point right here should be -2, 4, right? Let's look at the y values. See, we have a 4 here and a 4 here. They repeat more than once, so that's why it's not a one-to-one function. But I'm just curious, if it's not a one-to-one function, is it still a function, just a regular function? So remember, if you do a vertical line test, that determines if it's a function. It still only hits it once, so it's still technically a function, but it's not a one-to-one function. Does that kind of make sense? So yeah, a function could be a function, but it may not be a one-to-one function. Sometimes it's both, sometimes it's neither. So here's an example of a one-to-one function. Here's a typical linear graph. It passes the horizontal line test and it doesn't have the same y value more than once. So that's why it's a one-to-one function. See, as you can see, if I do a horizontal line test, it only hits it once. Now, is this just a regular function? Yes, if I do a vertical line test, it only hits it once. So two things with this graph. It's a one-to-one function and it's just a regular function. You're probably thinking, well, what's a one-to-one function? Like, what does it mean? So when you have a one-to-one function, you're gonna it has a relationship with inverses. So here, I'll show you what I mean. Whoops, did I go? I think I skipped something. Let me find it. Okay, so whoops. Sorry, I have to find. Okay, so let's do some conclusions. What do we know? So if a function is a one-to-one function, then it has an inverse. That's what we can conclude. If it's an inverse that has a one-to-one function, or if it's a one-to-one, it has an inverse. The domain of the inverse is the range of the regular f, just the untouched f. And the range of f inverse is the domain of regular f. So I'll show you what I mean by this when I'll give you an example. And then the graph of y of f of x and f of inverse are symmetric with respect to the line of y equal x. So what that means is, let's focus on two graphs. I'm going to focus on, we'll learn about more about this one later on in the section. So let's do a typical exponential graph of y equals 2x, right? If you don't really know this, because I don't think I've gone over this yet, but we will eventually. So this probably might sound foreign to you, but that's okay. So the exponential graph of y equals 2x has a y-intercept of 0, 1. So here's y equals 2x. It's a typical exponential graph, and it's increasing, right? So it has a y-intercept of 0, 1, and the domain is all real numbers. And the range is from 0 to positive infinity, and it's still technically a one-to-one function. Now let's now, what's the inverse of exponential graph? It would be the log graph. So if you look at the y equals log base 2x graph, it has an x-intercept of 0, 1. So remember the other one, the exponential was 0, we had a y-intercept of 0, 1. Notice that we just flipped it. We're switching the x and y's. That's pretty much what an inverse is. Like, you're switching the x and y's. So over here we have an x-intercept of 1, 0, and then the domain of this log graph is from 0 to positive infinity. And remember, the domain should be so the domain is 0 to positive infinity. It's also, remember from the exponential, it was also the range of the regular exponential graph, right? So that goes with this rule, right? The range of f of inverse is the domain of f. So that's rule number 3. What about the range of this one? So we have from negative infinity to positive infinity. The range is also the domain of the exponential graph, right? And they're both one-to-one. And then if you put an asymptote of a linear asymptote, right? Like this one, y equals x. Notice that they're symmetric. So if you fold it in like half, they're pretty much they're symmetric to each other. So that's what some of the properties of inverses and one-to-one functions. So I think so. Okay, now last one is, well, how do you find an inverse? So it's pretty much, it's not too hard. Here are the steps to find the inverse. First step is replace f of x with y. The second step is switch the x and y's. The third step is solve for y, and then the fourth step is replace y with f inverse. So we'll actually do some problems with that, and it's not hard. It's not too difficult. It's just a lot of algebra. Okay, so let's actually start to do some problems. So let me ask you, is this a one-to-one function? So let's see. Remember, we have to focus on the y value. So we have a y value here, 4, and a 3 here, and a 3 here, and a 4 here. So is this technically a one-to-one function? It's definitely not, because no, not a one-to-one, because the y value repeats more than once, right? We have a 4 here, 3, 3, 4. So the 4 repeats and 3 repeats. So you can't have repeating y values. So it may not be a one-to-one function, but is this just a regular function? Let's look at the x values. 5, 4, 3, 2. It's not one-to-one, but it's still technically still a function. Okay, that was that one. What about this one? Same rule. Is this a function? I mean a one-to-one function. So let's look at the y values. We only care about the y values for a one-to-one function. We have a 5, 3, 1, 2, 4. Any of these y value repeats? No. So yes, it's still technically, yes, it's a one-to-one function. One-to-one function. Okay. What about this one? Is this a one-to-one function? Let's do the, we don't know my y values, but we still can do the horizontal line test. So it hits it here once, another time, 2, 3. So a total of 3 times. So it fails the horizontal line test, so it's not a one-to-one function. And if you're just curious what kind of graph is this is a polynomial graph. And then we'll later learn how to graph polynomials later on in this section. Is it just can it be just a regular function? I think it can, because if you do a vertical line test, it only hits it once. So yes, it's still a function, but it's just not a one-to-one function. So what that means is if it's not a one-to-one function, it does not have an inverse. So if it does have a one-to-one function, it has an inverse. So that was a. What about this one? This is what's called a piecewise graph. Piecewise. Is this a one-to-one function? So it's kind of hard to see, but we don't, because it's kind of hard to do the horizontal line test. But let's look at the y values here. We have an open circle, and then it has a coordinate of 0, 1. So we have a 1 here, and then we also have an open circle piecewise function, and it has a -1 as a y value here. So the y aren't the same. So yes, it's still, yes, it's a one-to-one function. One-to-one function. I don't think it's a regular function, because it has an x value of x 0 and 0, so it repeats. So I don't think it's technically a function, but it's a one-to-one function, if that makes sense. What about this one? This upside parabola graph. We don't have the y value, so we're gonna have to do the horizontal line test. So it's here once, and then another time twice. So that's a total of 2 times. So no, not a one-to-one. I think it's still technically a function, because if you do a vertical line test, it only hits it once. So it's a function, but just not a one-to-one. What about this graph? This square root graph where it has a horizontal shift of -1. I think it is a function. Yes. The reason why it is a function, if I didn't have to use the horizontal line test, notice that this point here is -1, 0. This point here is 0, 1, and then if we put 2, it would be 1.7. Notice that the y value does not repeat. So we have a 0 here, 1 here, and then 1.7. It gradually increases, right? So the y value doesn't repeat, so that's why it's still, yes, it's a one-to-one. Okay. Now let's deal with inverses. So let's actually do an inverse problem. So the problem says we're given f of x equals 2x plus 7. We got to find the f of inverse. So remember, the first step is replace f of x with y. Replace f of x with y. So over here we have an f of x, so we're going to replace that with y. So it's y equals 2x plus 7. My second step is switch the x and y's. Switch the x and y's. Okay, so we're using y, we're going to replace that with an x. So it's going to be x equals, and whenever you see an x, you're going to replace that with y. So it's 2y plus 7. And then the third step is solve for y. Solve for y. So I'm going to solve for y. So what do I want to move this 7 to the left, so I'm going to subtract 7. Subtract 7, so we get x minus 7 equals 2y. And then divide everything by 2. So we get y equals x minus 7 over 2. And then the fourth step is replace y with f of inverse. So replace y with f of inverse. So this y here is we're going to replace it with f of inverse. X minus 7, whoops, over 2. And this should be your final answer. Or you could just move this 2. It could be right, 1/2 x minus 7/2. They're the same thing. Either answer is correct. So that's how you find the inverse. Let's do a few more. So let's do this rational. We got to find the inverse of this rational function. First step, replace f of x with y. So it's going to be y equals 2x over x plus 1. And then you're going to switch this. Then the second step is switch the x and y. So this is going to be x equals 2y plus y plus 1, right? So wherever you've seen x, you replace that with the y. And wherever you've seen y, you replace that with an x. The third step is to solve for y. So let me rewrite it right here. X equals 2y over y plus 1. My goal is to solve for y. So this has an invisible 1, and then what I'm going to do is cross multiply. Right? I'm going to cross multiply. So x times y plus 1 equals 1 times 2y, which is 2y. I'm going to FOIL out this x, so it's going to be xy plus x equals 2y. Now, what am I going to do next? What I do? So we have an xy plus x equals 2y. I want to get all the y's on one side, right? So we have a y here, and then we have an xy here. I want to move all the y's on the one side. So I'm going to remove this xy to the right. So I'm going to subtract xy, and you'll see why I did this. So you get x equals 2y minus xy. The reason why I combine the y's together is because I can actually factor that y out, right? So we have a y here and a y here, so I can actually factor it out. So I'm going to do factor out a y, so this is going to be 2 minus x. And then this stays the same, right? X. Now, remember we want to solve for y, so I have to get rid of this 2 minus x. So what I'm going to do is divide, since this is multiplying, I'm going to do the opposite. Divide 2 minus x from both sides. 2 minus x. So I get y equals, see this cancels, so y equals x over 2 minus x, right? And then my last step is replace y with f of inverse. So this is going to, my final answer is going to be f of inverse of x equals x divided by 2 minus x. And that's how you find the inverse of that one. I think one more problem, and then that'll be it for this section. So yeah, I want to find the inverse of this one. So first step, place that f of x with y. So it's going to be y equals 8x cubed minus 5. My next step is switch the x and y. So this is going to be an x equals 8y cubed minus 5. Next step is I'm going to solve for y. So let me move it. Let's put it right here. So I'm going to make this equals 8y cubed minus 5. So I want to solve for y. So what I'm going to do is add 5 to here on both sides. So I get x plus 5 equals 8y cubed, right? Let's get rid of this 8, so I'm going to divide everything by 8. So I get x plus 5 over 8 equals y cubed. Now I want to get rid of this cube, so how would I do that? I'm going to raise everything to the 1/3 power, right? Because when you're raising something to the power, you're multiplying the exponents. So it's like saying 3 times 1/3, which is 1, or just y. So this is going to be y equals, and then I have to raise this whole thing by 1/3. So it's going to be x plus 5 over 8 to the 1/3. Now, well, you could leave it like this. You could just leave it like, you can leave your answer like this, right? Or you can actually simplify it. So, but I could simplify it, but I want to, let's say if I did want to simplify it, let's move this 8. Let's not put the 8 in the denominator. Let's put it in the numerator. So what's another way of writing 1/8? You can rewrite 1/8 as 8 to the negative 1, right? So it's going to be 8 to the negative 1. And then you have this one, right? Times x plus 5. And then you're going to raise everything, that whole thing to 1/3 equals y. So remember, what happens is when you're raising exponents, you're multiplying the exponent power. So let's do the 8. So it's like saying negative 1 times 1/3, which is negative 1/3. So that's like saying 8 to the negative 1/3 times x plus 5 to the 1/3, right? This 8 to the negative 1/3 is equivalent to saying 1 over 8 to the 1/3, positive 1/3, and we know that's 8 to the 1/3 is 1, 2. It's 1/2, right? Because 8 to the 1/3 is 2, right? Okay, so 1/2 is equivalent to 0.5. So we could rewrite that 8 to the negative 1/3 as 0.5, and then we can rewrite x plus 5 to the 1/3 is equivalent to saying the cube root of x plus 5, right? That's the same thing. And then they're really close, so that means they're multiplying, so we can rewrite that as, it would be 0.5 cube root of x plus 5 equals y. And then the last step is replace that y with f of inverse, so it's going to be f of inverse of x equals 0.5 times cube root of x plus 5. And that's your final answer. So yeah, that wraps it up for this section.